Hey, 8th graders, part of your Chapter 2 test or assessment today is the 2.3 Force and Motion Modeling Quiz. So this is one of two things you guys will be completing today to close out Chapter 2. I'm just going to walk you guys through it, but your learning target for today, I can model how the velocity changes of objects of different masses when an equal force is applied. So we're going to be looking at our little ACM pod and how maybe the number of asteroids that they collected would change its mass and therefore change its motion after we apply that medium strength force, which we know is the same force that happened on all the other ACM missions. Okay, so on slide 2 in this activity, we'll model your ideas about how a more or less massive pod's motion would be affected by the same strength force. So again, remember that in our original pod, it moves in with the medium speed to the right, the thrusters fire a medium force, and generally that causes the pod to stop so it can dock with the space station. But in this case, we know that somehow the pod either turned around and moved in the other direction, whether it just turned around in general and moved in the other direction, or whether it only slowed down, hit the space station, bounced off, and moved in the other direction. So those are going to be the two things that you guys are modeling today. Okay, so if you guys remember in claim 1, you guys just had the pod turn around and move direction. So we know that there was nothing wrong with the thruster force, that they fired with the medium strength force. So you guys will show that in your model as well today. But you will also be just kind of the main thing we're looking for is, can you show me how that pod is going to turn around and move in the other direction based on the mass of the pod. Okay, so open the force and motion modeling tool activity. You guys have two different links to this. You'll do two different modeling tools. So for this one, we're going to do claim 1. So you guys can go ahead and right click, open that link, and then it's going to pull up this one here. So this is claim 1. If I look, I can see, all right, this pod's mass, model this pod's mass, so it shows that the usual thruster force would cause it to move in the opposite direction. So again, remember that claim 1 was where it just turned around and moved in the opposite direction. So here's kind of your little checklist of things you need to do. Choose an object that represents the mass of this pod. Drag it into all 3 panels in the second row. So you'll need 3 of that same object. And then you will show the pod's velocity in the before and after force panels, and then show the direction and strength of the thruster force in the during force panel. Okay, so if we look at our modeling tool here, this is our normal thrusters like I was just talking about, where we have the medium massed puck or the pod. It's moving at a medium speed to the right. The thrusters fire with the medium force to the left, and that causes the pod to stop. But again, we know the pod didn't stop. There was nothing wrong with the thruster force, so make sure you guys are thinking about that as you guys work through this. All right, so you guys are going to decide, all right, was it a normal pod and had the medium mass? Was it smaller than normal with less asteroids and had a smaller mass than normal? Or was it a large mass with more asteroids than normal that had a larger mass? So whatever you guys choose for your puck, you're going to do for all 3 of these. So if I chose puck A, I'm going to put A, and A. If I choose puck B, I'm going to put 3 of them in these 3 boxes. If I choose C, I put these 3. Again, when you're thinking about this, the biggest thing is you're thinking about is which mass would cause that pod to move in the opposite direction if we have a normal thruster force acting on that pod like any other mission. Okay, so go ahead, take a second, put your 3 pods. They should all be the same. Whatever you choose, they should be the same in all 3 of these boxes. Okay, once you guys are done with that, you're going to go ahead and model the size of the thruster force. Remember, we found out the thrusters weren't broken, so that should give you a pretty big hint about which thruster force you're using for the middle part. And then show me what happens if, again, our pod is turning around and moving in the opposite direction in your goal here. Okay, so make sure you guys use the correct velocity to show the after force part. Okay, once you guys are done with that, those 3 things, so you should have 3 pucks that are all the same. You should have a pink arrow in the middle box to show the thruster force, and you should have one of these velocity little tailwinds to show the movement of the pod after the thrusters fire. Okay, so a couple different things you're looking for. Once you guys are done with that, screenshot it, put it in on slide 4. Okay, then you're going to exit out of that link. You're going to go into a new link. Again, it shows you guys the normal ACM pod. So again, medium speed, moving to the right with medium velocity, medium mass. We have a medium thruster force that fires in the opposite direction. That causes the pod to stop. Okay, so again, the only thing you guys are modeling is these 3 boxes right here. In this one, if we look at our instructions, you're going to model the pod's mass so that it shows that the usual thruster force would only slow the pod down and not stop it. Okay, so we know eventually it's going to hit the space station and turn around and then move in the opposite direction. So you guys are just modeling the part where before it hits the space station. So same like you guys did last time, you're going to choose which mass of object, whatever you guys choose, you're going to put in all 3 boxes. So if you choose A, which is the lighter one, you're gonna put that one in all three boxes. If you chose B, which is your normal pod, you're gonna put a B in all three boxes. And if you decide it's larger than normal, you're gonna put a C in all three boxes. Okay, once you guys have the same puck in all three of these boxes, you're gonna go ahead and grab a pink arrow to show what the normal thruster force would look like. Remember, again, nothing was wrong with our thrusters. Okay, and then after the thrusters kick on, what would that cause the pod to do as far as its motion? Again, think back of what your goal is. Okay, your goal is that it just slowed the pod down, it didn't stop it. So use the correct velocity to show this. So again, to sum up, you should have the same puck in all three boxes, so 3 of the same puck. You guys should have a pink arrow in the middle box, and then you should have one of these low velocity tailwinds in your end box to show the movement after the thruster force. Okay, again, once you're done with that, you're gonna go ahead and screenshot it. Let's put that one on 6. Make sure you guys have both of those screenshots saved. I won't be able to grade it without both of those screenshots. And then go ahead, you guys can hand that in and move on and make sure you guys take the other part of the chapter 2 test. Hope you're having a great day.